Uh, okay, I'm Duke-Woolley. I'm the CEO of Beecham Research, which is an analyst company. We've been specializing in the IoT space now for somewhat over 20 years. So we've seen a lot of things moving from what was traditionally M2M into IoT and beyond. So I'd like to now let my panelists introduce themselves and where they fit into the IoT space. So, Terry.
So I'm Terry Moore. I'm the CEO and founder of MCCI Corporation. We're a systems software company in the most general sense. But specifically in IoT, we do all kinds of software and systems work for our customers. I've been involved with industrial controls off and on my entire career. I started in the 70s and 80s doing microprocessor-based things and then moved into the PC business and back into IoT about 10 years ago.
Great.
Hello everyone, so my name is Chakib Berkani. I'm actually a business developer at Kerlink. Kerlink is a French gateway manufacturer specialized in the LoRaWAN industry. And basically we help clients and integrators to build their network, to build their LoRaWAN networks, and either by providing gateways, but also by providing some maintenance tools, some platform to help them maintain their network.
That's great, okay. So part of what we're going to talk about is low power design and stuff like that. But before we get onto that, we wanted to talk about capacity in the network and how that needs to be built in. Does it need to be built in to start with, or do you escalate it over time? And that will then lead on, I think, to a discussion about power requirements and power design in the future. So Terry, I don't know if you'd like to start that off. What are the issues surrounding network design when it comes to capacity for LoRaWAN?
You know, the first issue really is where you're going to place the gateways. Because they require power, generally. Yeah. They typically require backhaul. It depends very much on your installation, whether you can use the backhaul that's available from the site or whether you need to use cellular for your backhaul.
Right.
So there's always a question when you're doing a greenfield deployment, is a device going to be covered or not? And so I think the title of this thing is like, do you saturate, do you use more gateways than you think you need, or do you just sort of deploy opportunistically? And I'm sure the gateway manufacturer can really tell you more about what works for people. We tend, in our deployments, MCCI has done a lot of deployments for a lot of customers. We tend to be more opportunistic, but the metrics, we'll come back to it. The metrics for goodness aren't just the data going through, but there's also power considerations in the devices.
Yeah, okay.
Yeah, so maybe from a gateway manufacturer perspective, capacity is actually quite theoretical when we talk about capacity in LoRaWAN and gateways. For instance, you would find in data sheet in gateway manufacturers that they can maybe transmit 700,000 messages per day, 1.4 million messages per day. But that's not exactly true because it depends on a lot of factors, as Terry said. The use of the spreading factors, for example, the use of the backhauling, how far the gateways are from the sensors, right. The frequency of transmissions, and so on. So it's not quite easy to know at first, for example, how many gateways do you use and where to put them, how many sensors you use, and so on. So basically, when you want to build a LoRaWAN network, usually you have two choices. As Terry said, either you build you put enough gateways and then you put redundancy and so on so that it can cover all the sensors, or you actually do a design or what we call a network study, and that's when you know exactly, you do a study of the coverage, you do the placement of the gateways, you know how many gateways do you need, you also study the redundancy, you study the if there are any bottlenecks and so on. So basically you have two options, and both options I would say have their advantages and disadvantages. For instance, the first option of the study would allow you, obviously, to build your network, but if you want to scale up, it would be a bit complicated because you might need to add more cost, to add more gateways, and so on. Whereas the second option, where you put more gateways, it would be a little bit costly at first, because obviously you are putting more gateways than the sensor that you need. But eventually, if you want to scale up, if you want to add more sensors, then it would be easier, and it would, well, you would have your return on investment.
Right. Okay. So a huge issue as part of that is power, the need for power, and of course we have the title of this conference is Low Power Internet of Things, so we ought to talk about that as well. So we're leading to lower power because that's more sustainable, that's better for the industry overall, and all these other things and stuff like that. But that leads to some key issues, I think, about how do you make low power. What would you say, Terry, are the main issues surrounding providing low power at the moment?
Well, so for devices, you know, there's lots more devices than gateways, and
That's it.
for devices, then that you do not want to have to visit the devices very often.
Right.
They're often inaccessible. It's sort of like deploying satellites.
Yeah.
In fact,
Right.
So that says you really want to maximize the battery life if you're not going to be using some kind of energy harvesting.
Right.
The number one way to maximize battery life is managing your transmitter on the device, because when you key the transmitter on the device, you immediately have about 100 milliamperes of load on your battery to power the transmitter.
Right.
The number two way is the receiver, but that's like a factor of 10 less. So you focus on managing your transmit power. And managing your transmit power is not just the size of your packets, which is of course a factor. Each byte costs you battery life, but it's also what data rate you're using.
Okay.
What spreading factor? LoRaWAN, has got many spreading factors or data rates depending on which spec you're reading. It goes from very slow to very fast, relatively fast. And relatively fast, you're on the network, transmitting, you're off quickly. It's a big win. Relatively slow, it's exponential, binary exponential as you go each spreading factor for the amount of time that you use to send your data. So, you go from, in the US, you go from spreading factor 7 to spreading factor 10. Spreading factor 10 is not just 3 times worse, it's 8 times worse for power.
Okay.
And you've got a packet size limitation in the US, which says if you want, you can only send 11 bytes at spreading factors 10. So if you're sending lots of bytes, you've got to send many packets, which adds overhead, and it gets worse and worse and worse. So you've got to manage that. How do you manage that? Network capacity. You have to have enough gateways so that the network will keep your device in the fastest transmit rate, so that you're going to get on and off the network quickly. And that comes back to the gateway folks.
Okay. All right. From a gateway perspective, you're acting as a hub often for lots and lots of devices, and that adds a power requirement. But then, if you've got individual devices, they can conserve power to some extent by sending messages every so often. But the hub can't do that because it's got to send the data anyway. So what are the issues from a gateway perspective on power?
Well, if you, as Terry said, from a gateway perspective, if you, for example, don't put enough gateways and then you have many sensors who are transmitting with a high frequency, for example, you might have some bottlenecks, you might have some lost packages. And that's not what we want, and especially not what the clients want. So from our perspective, what we can do to, let's say, optimize this process is sometimes we try to keep the data in the gateways so that reduce also the consumption of the gateway itself. So we, let's say, optimize the use of the modem, optimize the use of the backhauling by using some edge on the gateway. So that's one solution to do that. Now, from a sensor point of view, and maybe Terry is the expert, but I think from a sensor point of view, having a sensor with 7 years or 10 years of lifetime is quite important for clients now. I think some might even might even be targeting a lifetime or autonomous, let's say sensors, because obviously if you put a sensor in a forest, if you put a sensor in the middle of the ocean, underground, obviously you don't have access to that sensor to change it every 5 years or every 6 years. So the idea is to put a sensor and then forget it for 20 years or even for a lifetime.
Yep.
So in the last session that I was running half an hour ago, there was a lot of discussion about energy harvesting and using energy harvesting as opposed to batteries. Would you see that as being an increasing part of the need for conserving energy in what you're doing in gateways, or not?
In terms of sensors, or
Well, so the opportunity for energy harvesting, if you like, to conserve power, would you see that as an important aspect of your activities?
well, yeah, definitely. We actually, for example, in terms of gateways, obviously, we are trying to release some autonomous gateways, for example, that work on solar energy, wind energy, because obviously we also found it difficult, or clients found it difficult to get some power sources
Right.
sometimes in,
Right.
as I said, in difficult areas. And even if they can get some power sources, the cost would be huge. So instead of paying, I don't know how much, thousands of dollars every month to power the gateway, so we should maybe invest in a solar panel, in autonomous gateways to just take care of this issue.
Yeah, you know, the design considerations for gateways are very much different than the design considerations for devices, because gateways are, between 2 and 10 watts,
Right.
sort of continuously.
Yes.
Because they're running the
Yes.
radio, they can't control when the devices transmit, so the radio's got to be up.
Yeah.
And even though receiving is lower power than transmitting, the receiving for LoRaWAN is multi-channel concurrently. They're running a fairly complicated chip that's switching all the time, and so the power
Yeah.
is significant.
Yeah.
For devices, you've got, in order to get your long-term battery life, once you turn your transmit rate down to something reasonable, like once an hour or something like that, then you switch to sort of all of the classic low-power design techniques, shutting things down, sleeping the CPU, stopping clocks. There's a number of standard techniques to get down to the microwatt level or nanowatt. So you want to really, really, really be low power. Because you're really low average power, once you do this, then you can look at some of the other energy harvesting techniques. You can look at, vibration or RF or
Right.
all these other sort of advanced things.
Yeah.
But it still is there's a lot of power management becomes, your system,
Yes.
and your software design becomes power driven.
Yes. No, absolutely. Yeah. So, what would you say are the big challenges looking at power, use of power and design of products for power over the next few years?
The biggest challenge is, there's one big challenge, which is a lot of people want to do AI on the edge. It's very hard to do that low power with
Yeah.
energy harvesting.
Right.
So, and similarly, there are a lot of interesting sensors that require continuous power in order to do their job. For example, we do some work with gas sensors, the high electrochemical gas sensors. They can measure lots of interesting things, but they require continuous power to do their work because they don't power off and on quickly.
Right.
They're
Right.
very slow to come up,
Right.
very slow by measured in hours to stabilize. So you can't switch the power off and on. So now you got to provide them with power. Where does that come from?
Yes. Yes. Well, are you finding the same thing, use of the potential use of AI as being a big power user for your gateways?
Well, I think the idea behind maybe using the AI is to exactly predict the consumption of either the sensor or the gateway in real time. Um, well, to be honest, I don't know if it's a good idea or not. But until now, we didn't really do it on our gateways. We didn't feel the need to do it on our gateways because I think the gateways are a little bit more predictable, the consumption a little bit more than the sensors, as Terry said as well. There are way more sensors outside than the gateways. So for now, I wouldn't think it's
Yeah, so
necessary.
Jerry sort of indicated AI as being a key challenge. Would you see other key challenges for gateways moving forward?
I think the main key challenge right now for the gateway, I would say the access to power. As I said, obviously, if we take some southern countries where you have enough sun, where you have maybe enough wind to generate your power by yourself, you can solve the problems. But if you go up north, then it would be much more complicated. So that's the challenge that we are facing right now. I would say in the gateway perspective, we don't really. I don't think there is any solution on the market that can address or where we can put a gateway in the northern pole and then it would work. And in addition to that, deploying a gateway there or getting power there is way more expensive than, well, obviously in Europe or in Southern Europe. So I think that's the main challenge that we are facing when it comes to gateway and power.
So that's interesting. I mean, there are different issues in different parts of the world. Perhaps we could just explore that a little bit more because we've got North America and we've got Europe, which are big markets, and also China. But the other areas of the world, like India and Southeast Asia, for example, are growing much more quickly, and South America as well. So what are there different issues in different parts of the world that you see as far as challenges for power in the future?
Well, certainly. I mean, in the extreme, the extreme northern or southern hemisphere.
Yeah.
You definitely. I mean, getting devices deployed when it drops to -30, routinely.
When you say extreme south,
southern, well, by Antarctica.
Oh, you do. Oh, you
Yeah,
right in the south. Yeah, okay.
Where it gets cold.
Yeah.
Or up in the mountains of Chile or something like that.
Right.
We actually are doing a deployment of monitoring maple trees that they produce sugar. Sugar is high value, and so and it get in Canada and northern New York State, it drops down routinely to -30, and battery packs drop out at -30.
Yes.
So you've got to charge these batteries from solar, but you got to keep the batteries warm enough to be able to operate. So it's an interesting problem. And this is these sensors. We're monitoring the pressure of the sap and a bunch of other things. There are a bunch of sensors that want continuous power.
Yeah, right.
So it's an interesting problem.
Yeah.
Things freeze up.
Okay. So from a gateway perspective, are the different regions? Do you see a different sort of profile of requirements for different regions?
I think when it comes to power, not really, because obviously if you have a source of power, then the problem is solved. As I said, the gateway consume between, let's say, 2 and 8 watts, so it's not a big issue. And usually also you put one gateway for thousands or hundreds of devices. So I think once you solve the problem of the power, either by a solar panel or either by getting some other source of power, I think the issue might be solved. I think the bigger issue is from the side of the sensors eventually.
Right.
Yeah.
Okay. All right. So looking to the future, then, what do you see as the sort of trends coming up? You talked about AI, but what do you see as the trends coming up and the and the new technologies that are coming up that are going to be of particular import for power use?
So I mean, for right now we're starting to see a generational change to the newer microprocessors and so forth. And
Sorry,
a generational switch to slightly larger microprocessors and newer process points, and so the power, generally you get a power advantage from that.
Yes, right.
But the what I think right now, in terms of the challenge right now is at the system level, because we're starting to deploy more and more devices, and people are starting to see what the challenges of sustaining these things are.
Right.
I mean, in industrial controls, the product life is extremely long. I did industrial controls until the late 80s, and I still last year got calls on systems we deployed in the late 80s. So
Right.
So we will be getting calls on LoRaWAN systems for as long as the devices are physically operating.
Yeah.
And so that causes a big challenge for the organization to maintain the capacity to sustain that.
Yes.
And so we're learning about that now.
Yeah. And you find that?
Yeah, I definitely agree. So I think maybe the big challenge that we can solve in the future would be designing maybe sensors who would be completely autonomous, that they can stay alive, let's say, and stay working by using maybe some solar energy or mechanical energy, and that would do a lot of let's say a lot of work in terms of sustainability, in terms of manufacturing, but also in terms of operating the network and the sensors that you have. So once you put, let's say, a sensor in the middle of the ocean, you just forget about it for 40 years or 50 years. So even from a sustainability point of view, that would be a huge success, I would say.
That's great. Do you have any last words?
Yeah, I just, I totally agree with what he's saying, that there's what's going to happen is the industry needs to get a level of experience with field deployment of these harvesting technologies, and really figure out how to do it in a way that, you've got thousands of devices out there and none of them are causing you problems.
Right. Okay, well, that's very good. That's the end of that session. So thanks very much.
Thank you.
And thank you for your for answering those questions that I just put. Thanks very much. Okay.
Thank you.